Yeah, hello. My name is Admiral Hal Gehman, U.S. Navy retired, and I was the chairman of the Columbia Accident Investigation Board. I completed 35 years of Navy service in 2000 and had served on a national level board before and since. On the day of the accident, February 1st, I was visiting my parents in Williamsburg, Virginia. I live in Virginia Beach, Virginia, and it's about an hour away. And we had been in meetings all morning, and consequently I did not hear about the accident. When I was finished and my meetings were over, I got in the car to start my trip home. I turned on the radio, I heard about the accident, and almost simultaneously my cell phone rang. And it was the office of the Assistant Administrator, Fred Gregory, who immediately put Mr. Gregory on the line, and he explained what was happening and explained the accident. I had not had an opportunity to digest or really comprehend what had happened because the telephone call came within minutes of the little news broadcast. And so he filled me in and asked me if I would serve as the chairman of what he described as a standing investigation committee that NASA has a standing instruction on what to do in cases like this, and all they needed to do was appoint a chairman. And so I said I would. So anyway, I drove home.
Right.
And called my wife, and she was skeptical about space shuttles, knowing that I have no background in space and I'm not an aviator. And this is one of the things that Fred and I talked about on the telephone. I said, Fred Gregory and I did not know each other. The administrator of NASA, Sean O'Keefe, and I had met a couple times, but we were not friends. We had only just met in the course of business when he was Secretary of the Navy and things like that. And I reminded them that I wasn't an aviator, if that made any difference. And they said, no, that's not what we're looking for. We're looking for somebody who's familiar with big organizations and how they work, and being an aviator wasn't a requirement. So then I drove on home, and NASA started dumping things into my computer so I could read ahead before a telephone conference that evening. The accident, of course, happened on Saturday, and we had a telephone conference Saturday night with NASA headquarters in which they described to me the processes that are already in place and the procedures, all of which was new to me. And of course, I had some read-ahead material that they had sent to me. And on Sunday, those of us that could, which was most of the board, traveled to Barksdale Air Force Base by various means. Some went commercial. A couple of us went in a chartered plane that NASA organized for us, went around and picked up a couple people. On the flight then into Barksdale, there were myself and 3 board members. And we talked on the way down, and I made the point that we need to make a running start. I'm not going to build this thing up slowly and sit in the background while we accumulate staff and things like that. We want to start immediately. And so we agreed that it would be a good idea that we would gather everybody that was possible there on Sunday night, as soon as we got into Barksdale, and have a meeting which discussed not so much the investigation, but organization and philosophy and also several of the people, for example, Major General John Barry, who was one of the officers on the airplane, had been on the Challenger investigation. And some of the NASA people that were seconded to us had a previous experience. So we wanted to mine all that experience in order to build a roadmap for at least the first 2 days, so that we got a running start. So that first night, what we discussed was process. We didn't discuss the accident or anything like that. We discussed such things as what briefings do we want from NASA, in what order? How much do we personally know about shuttles and solid rocket boosters, and how much do we know about NASA engineering, and how much do we know about NASA organization? And some people knew a lot, and most of us didn't know very much at all. So out of that came a list of briefings that we wanted. some of the things we wanted to do early, some of the people we wanted to meet early. So it was process. It wasn't any investigating. And I think that got us, I think that was important. That's one of the lessons, I think, is that even though the entire board had not assembled by that time, I think they were still missing one or two people. We had a quorum, and we were able to get a running start such that it looked like a lot of activity was happening very, very quickly. And that was one of my goals. After that meeting, I decided on my own that I wanted to go out and meet the press, which was camped outside the gates at Barksdale Air Force Base. And I just wanted them to see that we were there, we were at work, we were moving quickly, that we had all the expertise that we needed, and that we were going to be serious and inquisitive and professional. And I just wanted them, I wanted to get out there and have my face and my story on the press, because I knew that the press was going to fill in the time by making it up. In other words, they were going to do the best they can by speculating as to what was going on, and that would have meant that we would have had to spend some time undoing that. So I wanted to get out there early, get my story on the wires first, and it worked. They appreciated it. We didn't hold a press conference. I just walked outside the gate, and there were about 6 or 8 of the network people that they're milling around, and the NASA press guy and the Barksdale press guy went and gathered. We took about 5 minutes for them to get their cameras going, and I mean they were all frantic, and I said, I'm sorry, we're going to do this in 10 minutes, and I'm going to tell you what I know, and then I'm leaving. And it worked. It worked, and so that was the story that ran that night, and that's what I wanted. My relationships with the administrator of NASA, Sean O'Keefe, of course, were key and important. As I said, we were not personal friends. We didn't know each other very well. We had met before in the course of our professional life when he was the Secretary of the Navy. And we had a number of organizational issues which came up right away. The charter, for example. We wanted to look at the charter, and we wanted to expand the scope of the charter and make it clear and things like that. And there were a number of issues that required us and NASA agreeing on. To make sure that we didn't have any conflicts with the administrator, either he called me or I called him frequently to iron out differences of opinion or new matters or things we wanted to change, such that he didn't hear about it from the press, or he didn't hear about it outside the official chain. And it worked. It worked very, very well. Some things he pushed back on, I want to do this, or you should do this, or that's not a good idea, or some things I pushed hard on. But in any case, we ironed them out in the concept. We ironed them out at the highest of levels, such that when you get to the iron major stage, that somebody didn't bring these things to a halt. So a whole series of issues like expanding the board, changing the charter, moving from Barksdale to Houston, taking charge of the investigation from the Johnson Space Center when we took charge. All that was coordinated with the administrator in advance, so that neither he nor I got ourselves into any unnecessary conflicts. There were other issues that he felt strongly and pushed back on, and we worked our way through them all. That's another lesson in that don't leave these issues to be worked out by the staffs, because the staffs will get defensive of their organization, and you'll have a conflict where none is necessary. When we got to Barksdale, of course, we at NASA, and we were in a recovery mode. We were picking up debris. We had not found any remains. A lot of the debris we thought might be dangerous. We didn't know, but we were concerned about public safety, and so there were a lot of immediate issues that needed to be addressed, kind of housekeeping kind of issues that needed to be addressed. But in order to get on with the investigation, the board had to have a common understanding of the shuttle program, shuttle engineering, shuttle management, human spaceflight management, and all that kind of stuff. So we asked NASA to bring to us for several hours a day, not full time, but several hours a day, basic Shuttle 101, as we like to call it. How is the program organized? How did the shuttle work? What are the parts? How does the management work? Where's the money come from? Who's in charge? Who does engineering? Who does safety? Who does schedule? Who does payload? Who approves what? And in addition, and then the other hours of the day, we worked on other things like debris recovery and things like that. We did not hold formal press conferences. Johnson Space Center was holding formal conferences about progress and things like that because we were not we were not sophisticated enough and knowledgeable enough to take over that. Very soon into Shuttle 101, it became clear to the board that we were in the wrong place. Barksdale was the center of the debris recovery and the disaster recovery processes, but what the investigation into what happened to the shuttle required the engineering expertise, the technical expertise, and our ability to talk to and meet face to face with people, and all those people were in Houston, Texas. So I don't know if it was Monday night or Tuesday, but it was very shortly. Within 48 hours, we realized we were in the wrong place, and that picking up pieces of metal was not what we were hired to do. And we announced we were moving to Clear Lake, and we set NASA at work to find us an office and find us some place to move. And by Thursday, we were in Houston, and within 24 hours, then we took over the press conferences, took over all the press release. We took over, I think Friday, we took over the debris recovery teams. We started to take over the whole thing until within a few days, we owned the whole process, and the Houston and the Johnson Space Center got out of the whole process. There were a couple lessons there. One is I was not particularly anxious to start holding daily press conferences for two reasons. One is we were not knowledgeable enough, we weren't competent enough, and we would have looked like deer in headlights. The second is that press conferences take a lot of time, and the people at the Johnson Space Center were holding daily press conferences. And there was a little bit of shooting from the hip going on, and which was, I'm not being critical. They were trying to be as open and transparent with the press as they possibly could, and so there was a lot of speculating going on. And I wanted to get to the point where we could hold weekly press conferences. I thought that was enough, and also it would not, our whole life, their daily life would not revolve around getting ready for, holding, and recovering from a press conference. So it was good that the Johnson Space Center did it for the first 7 days or 6 days, and they did it daily. And then we had a weekend, we took a little break, and then we held our press conference, and I said, okay, from now on, they're going to be weekly. That worked out well, and the press was content with that. We decided, and it was offered to us by NASA, and we accepted an opportunity for every member of the board to fly in the entry simulator, particularly the last 10, 12, 15 minutes when you're actually flying and then making a landing. We all wanted to do that, and everybody did, including myself. We tried very hard in several ways, and I could enumerate them. We tried very hard to personalize this investigation and this accident. Everybody likes to say that the Space Shuttle Columbia was lost on entry, but actually it was 7 people that were lost. We also, for example, flew out into the debris recovery fields and walked around out in eastern Texas looking at shards of metal and talked to the recovery people. And we held a moment of silence out there. But it was all a part to personalize the accident, personalize the incident, and not allow it to get to be too technical, because I knew it was going to get technical. But these things are about human beings, and the board appreciated it. We also were able, in some tiny, small little way, to put ourselves in the shoes of all astronauts, not just these 7, what it's like to fly in the shuttle and things like that. So it was really an effort to personalize it. Once we got to Houston, we had to decide on processes and how to proceed. At first, because the shuttle was grounded and there were people up in the International Space Station, the shuttle was the main way of going back and forth. There was a chance that we could solve what happened here, fix whatever broke, and get the shuttle flying again. And that was our goal at first. And so we worked 7 days a week. And we worked hard to see if we could analyze what data we had and find whatever nut broke, or whatever bolt was loose and whatever fell off, and fix it. It quickly became apparent to us, after working very, very hard for 10, 14 days, nonstop weekends and late nights, that this was going to be harder to solve than we had hoped, and we are not going to be able to resume flying anytime soon. So we decided to reorganize ourselves and to build a different work plan. We attempted to visualize what the report would look like. We attempted to catalog what we knew and what we didn't know and what we would need to know. And a couple of important philosophical pillars were set at that time. One was, it was possible, this was my big worry, it was possible that no matter how long we investigated this, that we would end up with a big pile of circumstantial evidence, that we would never be able to prove, unlike Challenger, which was pretty obvious within 60 minutes what happened, that we would never be able to absolutely prove to our satisfaction or anybody else's satisfaction that we have found what caused the loss of the Columbia. And so I set about thinking through what the report would look like if it was just a big pile of circumstantial evidence, and what it would take to be able to pound my fist on the table and say, I know what happened to the Columbia. And after not a considerable amount of discussion, I mean, this wasn't something I just sat down and did myself. After a considerable amount of discussion about what constitutes evidence and what constitutes proof and what constitutes analysis and how much is enough, I decided upon multiple independent investigations, which I hoped would all end up pointing toward the same thing. Investigation number 1 would be the debris recovery and the reconstruction of the orbiter as best we could. And that, like the TWA airplane that went down over Long Island, where there was photographic evidence and eyewitnesses who saw something rise from the surface and rise up. And they swear that the plane was shot down. That it took a lot of analysis to figure out that a fuel tank ruptured and fuel was spewing through the air, and it caught fire, and the fire rose up. And so anyway, a second investigation was photographic investigation of everything we knew, a reconstruction of the accident based on aerodynamics and data recordings and things like that. So we had all these multiple independent investigations to try and determine what happened to the Columbia, and that was my answer to the circumstantial evidence conundrum. If I had 4 independent investigations and each of them had its own conclusion based on its own evidence, and they weren't relying on the other guy's analysis, and they all pointed to the same thing, then I felt pretty good about that. And we also had to come up with work programs and work hours, and several of our board members moved to Houston, including myself. Others commuted, so we couldn't work 6 days a week because they had other things they had to do. So we had to organize our meetings for when they were there and all that kind of stuff. Then we had to hire technical staff and stuff like that. So we went through all that. One of the important conclusions and agreements that we came to was that NASA and NASA's people were going to do almost all the work, and we were going to be like overseers or oversight. But we had to be smart enough, and I had to have the right people, so that when somebody was doing thermodynamic analysis or somebody was doing flight data analysis, that the person who was overseeing it for me was smart enough to know what was good and what was shoddy analysis. But the decision about having NASA do almost all the work was an important decision, because it would have cost a fortune for me to duplicate it. It was a matter of the press criticizing us for letting the investigators investigate the investigatees, but all of these things worked out, and so we settled down to a regular work pattern. We had the 4 independent teams then getting more photography, getting more flight data analysis, picking up more debris, doing metallurgy, doing thermodynamics analysis, and off we went. One of the things that I took away from that, one of the important things I took away from that is, if you are at the beginning of one of these complex investigations, you should never assume where the investigation is going to go. Even if you have a good, solid charter, or somebody says, find out why this widget broke, you should never foreclose your options as to where the investigation might go. And I was aware of that because of, for example, the investigation into the USS Cole terrorist attack took me places I never dreamed that it would take me. Another axiom that we bought into among ourselves, that we accepted among ourselves, was the axiom that complex systems almost always fail in complex ways. The press, the Congress, they wanted simple answers. And we said, no, you're not going to get a simple answer, because this is a very complex system, and it would be not useful for us to say foam hit the shuttle, blew a hole in the leading edge of the wing, and that was the end of it. It's much more complex than that. And so 2 big lessons that I would take away. One is that when you start one of these things, you never know where it's going to go. You should never preclude it going wherever it needs to go. And the second one is complex systems almost always fail in complex ways. At the very early in the investigation, we had long discussions about process. Process in the sense of interviews. Should they be sworn or not? Should they be confidential or not? Public hearings, documentary evidence, how to preserve it. We had many discussions about how to do this. The board members brought their own expertise to the board. We had NTSB people, and they had their way of doing it. We had Air Force, Chief of Air Force Safety and the Chief of Navy Safety, both a general and an admiral, and they had the military way of doing it. We had a couple lawyers that were there and were very helpful. Keeping in mind, I may get this wrong, but more than 90% of the shuttle program by weight is contractors, namely one big monster contractor. And the issue is, one of the issues that might come up is you might find contractor liability or culpability. Now tell me about evidence and statements and the ability of the board to get sued and et cetera. So we had to talk through all these processes, and then of course there are certain U.S. There's law that governs these things. FACA, FACA as it's called, about federally appointed commissions and boards, open hearings and announcing them the agenda 10 days in advance, et cetera, et cetera, et cetera. So we spent many hours trying to decide on board processes, and we adopted a modified kind of our own private system in which we used a little bit of the military system. The military system being, the military conducts two types of investigations. They conduct a safety investigation, which is done with confidentiality and anonymity, so you can say anything you want. And then they also conduct a formal JAG, Judge Advocate General investigation, which is public. And we adopted kind of a little of each. We had a public segment in which we did everything in front of the public, and we had a website, and we posted everything on the website. We held public hearings, we had press conferences, but then we also adopted a few of the safety investigation procedures where people could talk to us with confidentiality, and we would never release their names. Early on in an investigation, I believe that it's important not to preclude any avenue or path. You really don't know where these investigations are going to go. Even if you're limited by charter, you still should keep your options open and allow the thing enough latitude that at least the option will be presented to you to pursue something. There's another thing there's a second issue about these organizational decisions that we made the first week in Houston in dealing with NASA. I have always believed, and I think it's worth taking aboard, that large organizations are like organic beings, and that their first duty is self-preservation. And every time that I have investigated a large organization or poked at a large organization, it takes the natural reaction of any organic being and goes into a defensive crouch. All organizations do that. That's my own personal view. Large organizations are like organic beings, and their highest priority is self-preservation. I knew that, and so as we dealt with NASA and as we built our procedures and relationships, it's perfectly natural, it's to be expected that they would be defensive. And so once we knew that and we were armed with that knowledge, we were able to disarm it, and we were able to see through it and work our way through it without any difficulty. But in the process of deciding that we're going to let NASA do most all the work, we had to make ourselves aware of this natural large organization attitude. Worked fine. And under the experience we had of not knowing at the beginning where the Columbia accident investigation was going to go toward the end, And it turned out differently than I thought myself. It turned out differently. It's instructive that in the last weeks in August of 2003, when we had moved up here to Washington, D.C. to write the report, I received a telephone call from the executive director of the National Blackout Investigation Commission. You may recall that in August of 2003, everything from Buffalo, New York to Boston, Massachusetts, the whole grid went down. And the president appointed a national commission to investigate what happened. And this executive director, who I didn't know, called me and asked if I had any bits of wisdom for how to organize such a commission. And I told him, yes, I had one bit of wisdom for him, and this gets back to the axiom that I said, that complex systems always fail in complex ways. I said, if they tell you that a tree limb fell on a wire and broke the wire, caused a section of the grid to go down, and then it was a cascading failure after that, don't believe it. That's not what happened. It's far more complex than that. It has to do with training. It has to do with investment in infrastructure. It has to do with margin and redundancy. It has to do with all those things and more. And you would not be doing the nation a service if you said this thing was caused by a tree limb falling on a power line. Another axiom that I have found in investigating big organizations is that a lot of times when I read investigative reports, they come to the conclusion, they find what broke. They find the nut that broke or the branch that fell on the tree limb or whatever it is. Then they go back up the chain to find the first person in the chain and blame him. Because the first person up didn't do something right, or whatever he did didn't work. And sometimes, on a rare occasion, they might go up one more person and say he wasn't qualified to be in his position, or he was new, or something like that. And then they stop. So it's what these investigations, always what they do is they go find the mechanical widget that broke. They find the person who's closest to that widget and blame him. And sometimes they might go one person farther up the chain. They rarely go into the organization itself, leadership, money, finance, training, redundancy, margin, safety, engineering, research and development. Rarely does anybody ever look into those things because they're too mushy and too soft. And an investigation that seems to me that an investigation that goes and finds the widget that breaks and then goes and find the engineer who designed it and blame them for it, that's not a good investigation. And that's just my experience from having done a number of these. When we were well into the investigation, a couple of weeks into the investigation, a number of us sitting around having a cup of coffee decided to take on the project of kind of visualizing the end product. Not the findings, but what would the end product look like, and the idea or the purpose of doing this was to begin the process of working backwards from the end product to make sure that what we were doing today and next week really did lead toward a final report. One of the problems that we had was that since nobody knew what happened to the Columbia, the investigation was very widespread and could have gone on for a long time and could have spread out wider than it did. It turned out to be a pretty broad investigation anyway, but I was concerned that it remained focused. In order to do that, we attempted to visualize what it would look like and work backwards. And some of the board members who had served on other commissions and things like that opined that people in Washington, D.C. don't read anything that's more than 4 or 5 pages long. And you can have as many supporting documents as you want, but the report should be pithy and short and and something that a busy administrator can pick up, run through it, and go on to the next crisis. I came to a different conclusion, and I'm not exactly sure why I came to this conclusion. I will say that that one of the things that we did in preparation for this decision point, and I think this is worth taking away, one of the things we did was we studied other investigations. We spent a lot of time on the Concorde investigation. We spent a lot of time on the Challenger investigation. One of the reasons we spent a lot of time on the Concorde investigation is because the National Commission that investigated the Concorde got it wrong. The first report on the Concorde was wrong as to what happened to the Concorde. And they sent them back to do it again. And they came up, assumably they got it right the second time. I also had experience with other investigations that got it wrong. The U.S. Navy investigation into the explosion of the gun turret on the USS Iowa was wrong. And they wrote it. It was a magnificent document. 18 months later, it was proved to be incorrect. So based on that, I really wanted our report to stand alone. I didn't want you to have to go looking through annexes and appendices and other documents. I wanted it to tell a story, and I wanted it to string together from beginning to end. I wanted each statement to be a statement which imparted some information and was kind of self-explanatory. That led me to the conclusion that it would be a kind of a lengthy, voluminous report, but I wanted it to read like a novel. I really wanted it to read like a beach summer novel where you turn the page and say, oh no, tell me they're not going to do this. Oh no, they did it. You know, I wanted it to read like that. And so we had this big, long discussion, and we finally did it my way, and we envisioned what the thing would look like, and we started working backwards from that. Hence, we had to investigate things like historical budgets and missions and history and organizational changes and all kinds of things like, you know, why did the external tank get lighter and all that kind of stuff. So we investigated a lot of stuff because it all contributed. But it was all based upon a early discussion about visualizing what the final report was going to look like and working backwards from there. The report that we wrote, I am pleased to report, has stood the test of time, in my opinion. We're happy with what we wrote. We stand by the words, and we believe that it has weathered all kinds of scrutiny. Interestingly enough, as I go on the speaking circuit, and I was on the speaking circuit fairly heavily for a long time, everybody wants me to talk about risk assessment and risk management and not rockets and space and shuttles. They want to answer the question, how did a room full of the smartest people make such big mistakes? How does the best organization in the world know when it's making mistakes? And so people in risky enterprises like stationary nuclear power plants, medical people, things like that, graduate school, business schools, graduate schools, ethics courses. I've spoken at the Naval Academy ethics courses, Wharton School of Business, several times to professional associations of stationary nuclear power plant operators. And they all want to know the same thing, and that is, we have all these procedures, we got all these smart people, everybody's doing everything right. How are you supposed to know when you got a creeping problem that's sneaking up on you? And that's all in our report. The report is how is it that a smart organization makes a big organizational mistake and allows bad habits to creep into the organization, and that's what I talk about. I don't talk about space shuttles and rocket boosters and re-entry and stuff like that. I talk about risk and risk assessment, risk management, and how can you tell that when you're doing all the right things? The only thing that I would bring up in the regard of organizing an investigation and establishing kind of its philosophy or its macro level goals would be early on to make a list of your constituents. Who are you writing for? Now, clearly, if there's an investigation created, someone chartered it, someone gave you a charter, it has a purpose, and et cetera, et cetera. But that doesn't answer the question of who your constituents are. Your constituents, in our case, we had a lot of constituents. Congress was one of our constituents. NASA, of course, is not a cabinet-level agency. There is no cabinet-level person. There's no Department of Space. So the only oversight of NASA is by Congress and by the White House. So Congress, you might say NASA's boss is the Congress. So since we're investigating a part of NASA, Congress became one of our constituents. Certainly the families of the deceased astronauts were constituents of ours. The American public was a constituency of ours. So we thought about this, and we took it very seriously because we made sure that our loyalty was directed toward our constituents. For example, the administrator of NASA was not one of our constituents. Consequently, his feelings and his opinions were ranked lower down than, for example, the oversight committee, chairman of an oversight committee of Congress. So that drove a lot of what we did. That was very important, and of course the press was important too, and mostly how to get our message out. And because the White House and the executive branch and Congress were one of our constituents, then that meant I had to deal with them on at least a weekly basis, and that created the requirement to have a Washington office up here. I had to have a small 3 or 4 person office up here to liaison with Congress and the oversight committees and all the other people who were, quote, helping us do this investigation. As I mentioned once before, when you start one of these investigations, you should never assume you know where it's going to go. I had an open mind when I did the Columbia investigation, and I really didn't know where it was going to go. As it turned out, we went down several wrong roads. We came to several forks in the road and had to change our direction several times. At the very, very first, the investigation was focused on some telemetry data coming down from the Columbia that suggested what part of the shuttle saw heat the first. And that led us to believe that that's where the heat was coming from. Whatever temperature sensor showed temperature rises the first, we assumed that's where the heat was coming from, and it happened to be a wheel well sensor. And we assumed that somehow heat was getting into the wheel well. And we spent a lot of time on analyzing sensor data, sensor transmission, wheel well seals, and things like that. We spent a lot of time, weeks. But then the MADS, the data recorder, now shuttles don't have flight data recorders, but this one happened to have a mission recorder because it was the first shuttle. That was found in a field in Texas, and lo and behold, the thing was in pretty good shape. And that presented far more sensor data, far more sensor data. And that told a completely different story of where the heat came from. Completely different. We were completely wrong about where the heat was coming from. That's an important lesson, that you just don't know where these things are going to lead you, and you better not get completely in bed with a particular theory. So we were completely wrong about the wheel wells, and so was everybody else about wheel wells. The investigation went on, and the reconstruction went on, and we began to learn more and more, and become more and more interested in whether or not it was possible that the foam debris strike that occurred could have damaged the shuttle in some way. And of course, this was very controversial at NASA headquarters, or at Johnson Space Center, because they are quite convinced that foam can't hurt the shuttle. As we did more and more analysis, and we asked for more and more data, and we asked NASA to do this and do that, and look at this and look at that, my staff, both professional staff members and board members, who were invited to attend these engineering meetings and did attend the engineering meetings in an oversight as an observer kind of a role, started coming back telling me stories of very disturbing practices and habits that they observed in the conduct of these meetings. In some cases, dissension was not permitted, minority opinions were not welcome. If you weren't at the right space center, you were ignored. Very unprofessional and very disturbing practices, not always, not by everybody, but more often than we would have liked to have seen. So, as you may know, after one of the lessons learned, and one of the recommendations from the Challenger accident was that all these flight meetings had to be recorded. So we decided to go back and look at meetings that were held during the flight, before the flight, and because they were all recorded. And lo and behold, some of these managerial, leadership, organizational traits that we didn't particularly like, we found some of them in some of these flight meetings. And that caused us then to ask ourselves whether or not we want to begin to look into the whole area of management, because we had not touched that. Several of us on the board were skeptical about whether or not we wanted to even go down that road or not. We were skeptical for several reasons. One is I wasn't sure that anything particularly good would come from it. And second, but the main reason was I was not well versed in the business of risk assessment, risk management, to know whether or not the level of knowledge and the level of accepted practices was high enough and accepted enough that we would have a benchmark against which to measure what we were seeing. So we went out and got a panel of 6, 8, 10 really, really smart risk management, risk assessment practitioners, people out there in the field doing very, very risky kinds of things, and academia from centers that are known to be experts in this. And we brought them in to educate us as to whether or not this was a field in which there was good, hard standards, good, hard knowledge against which we could measure these NASA managerial meetings. We became convinced that that was the case, that there is a good body of knowledge of risk management, and we built kind of a matrix of a good risk management organization, applied the matrix against some of the meetings we saw, and came to the conclusion that this was part of the problem. And that's a fork in the road that we had no clue in February that we were going to start down. Turned out to be one of the biggest, most important contributions we made, in our opinion. We had a bit of a challenge in this Columbia Accident Investigation Board to weave our way through federal commission regulations, the confidentiality issues that we had established with respect to the anonymity of certain safety people and engineers that we interviewed, and the requirement to be transparent and hold press conferences and things like that. And one of the federal regulations is that our boss's IG at the end was going to have to certify that we were independent. He didn't have to certify our findings. He just had to certify that our processes and that we were independent. And this was a constant minor issue. This was not one of the big things that drove us, but we had to continuously weave ourselves between the posts of the side of the road of transparency and being responsible to the public and conforming with the federal regulations, and also our requirement to have our desire to have some of the things we did to be confidential. And I believe that we did that. Probably the most contentious issue was with the oversight committees of Congress, who wanted us to turn over the confidential interviews, which we refused. They held a hearing in which they called me up and were pretty rough on me, and we compromised by creating a congressional reading room where designated members of the staff, not anybody on the staff, they had to designate members of the staff, or of course the members themselves, could come over and read anybody's statement that they wanted to. In the case of the chairman, we actually would take the material over to the chairman's office, and if the chairman wanted to see something that somebody had said, he could do that. That conflict was much more public and much more serious than whether or not the NASA IG could sit in on our meetings or things like that. I don't remember that being a particularly big issue. But the subject of independence is a big issue. People ask the question, for example, we are spending NASA's money, so how can you be independent of NASA? Well, there are ways to do that. You set up a separate account and a separate line item, and you have control of it, not NASA. How can you be independent of NASA if you're working in the NASA offices? Very simple. Go rent an office building down the street. I mean, there's ways to do that and be independent. And I think we managed to work our way through that. This board was different than the Challenger board. The Challenger board, of course, was a very, very high level, presidentially appointed commission led by the retired Secretary of State Rogers, appointed by the president, et cetera, et cetera. And so it had a lot of gravitas, as the press likes to say. We were kind of a working class, roll up your sleeve, professional accident investigator, kind of a group of people appointed by NASA. And so both the Congress and the press criticized us and criticized NASA. Doing it the way Mr. O'Keefe wanted it done, by having the Columbia Accident Investigation Board do it, was reaffirmed by the White House, and so it all went away. Nevertheless, the oversight committees and the members of the press remained skeptical. And I considered that to be in my job description. I didn't need to be going around Texas picking up debris, and I didn't need to be doing thermodynamic analysis. But getting the Congress on our side and getting the press on our side was clearly my job. So I set about it quite hard, worked it hard, made office calls, walked around Capitol Hill, got to know the people. They got to know me to where they could pick up the phone and call me if there was a rumor going around Washington or something. So I found out about it right away and was able to address it quickly. We had to establish our bona fides in the eyes, at least, of the press and the eyes of Congress. We didn't need to establish our bona fides in our own eyes because I had the world's best aircraft accident investigators on my group here. Nobody was going to second guess us technically or procedurally. But the press and the Congress were skeptical, and it was my job. That was my job to convince them that we were independent and that we were serious, and we would take this thing wherever it went, and we would lay our findings out without any influence from NASA. And so I worked hard at it, and I would tell anybody that had to do an investigation like this that they should not avoid working with the press, and they should not avoid members of Congress. I know a lot of military officers who have been brought up in the military to stay as far away from Congress and stay as far away from the press as you possibly can. I was not one of those military officers. I was brought up the other way. You got to work with Congress and you got to work with the press. So it was not any kind of a heroic action on my part. It was kind of a natural thing that I know who my boss is, I know who my constituents are, and so I go and make sure that they're content. And so I did that, and it took some time, a bunch of trips between Houston and Washington, and a bunch of press conferences, and I had some really good help. I had a wonderful press team, and I had a wonderful Washington liaison office. Part of the board was a standing accident investigation team. They're professional accident investigators, and by the way, conceptually, the Columbia accident was an aircraft accident. I mean, there was no rockets involved. There's no powered flight involved. The thing has wings. It was in the atmosphere. Now, it was going a little bit faster and a little bit higher than normal aircraft, but it was essentially an aircraft accident investigation. I mean, it's not hard. It's not hard to make that decision, at least at the front. And so we had really, really smart aircraft accident investigation people. I didn't have any problem. I didn't have any problem with that. But then the scope or the universe becomes larger when you start thinking about the shuttle program, and how it got into orbit, and how did it get up there, and how is it supposed to get back down, and why does it do the things that it does, and the issues involved, the flight dynamics involved, the thermodynamics involved, everything involved becomes bigger and more and broader. And I felt that for myself, and I also thought that it would be helpful to the board's deliberations if we all had kind of a common basis of knowledge of the shuttle program and shuttles in particular. So I started an education program, and we spent part of our time each week listening to people who were not part of the investigation, to learn about spacewalks, to learn about entry dynamics and things like that, to learn about RCC and foam, and to learn about the shuttle universe, just so that we were broader based, that we had a better way of comprehending details that were presented to us. And I'm a person that's not afraid to say when I don't know something. And so I can't tell you how many meetings I went to in which I raised my hand and said, hey, wait a minute, you're talking about something that I don't know anything about, so explain yourself. So I didn't have any problem insisting that the board go through a kind of an education process to broaden its understanding of what we were dealing with. One of the processes that we agreed upon was that whenever we discovered anything, or whenever we came to any conclusion at any point in the investigation, that we would make it public and NASA would be informed. In other words, this was not going to be a gotcha kind of an investigation in which we wait to the very end and dump the thing on the table. Consequently, as we learned things and as we came to a conclusion, a finding, as we agreed upon a finding, and from the finding would result one or more recommendations, we would release those as we agreed upon them. And so if we came upon the conclusion or a finding, for example, that the fact that the human spaceflight program is 95% contracted to the United Space Alliance was not a factor, we would announce that right away. And, or on the other hand, if something that should be investigated or fixed before return to flight, we would announce that right away. We wouldn't wait for the end to come out. Consequently, a few, half a dozen findings and recommendations were released periodically as we went along, and that way we prevented surprises at the end, and we always let NASA know. We informed NASA formally of what the finding was going to be in advance to make sure we didn't make a big mistake. I mean, sometimes even we make mistakes, and sometimes you come to a finding, and the experts say no, that's not right. that you're wrong, and so we wanted to make sure all that got aired out at the staff level and not in the New York Times. During the course of the investigation, after we had taken several forks in the road and became interested in the issue of whether or not it's possible that the foam debris which struck the leading edge of the wing could possibly have been a cause. We didn't know it at the time, but we had to get much more serious about the engineering and the pedigree and a much deeper understanding of what was this foam and how strong was it and why do you use it and what's it made out of and why is it there in the first place, et cetera, et cetera. And so as a way of encouraging the staff to seriously delve into this, I used the old investigative axiom of follow the money. In this case, I said follow the foam. And I want to know about foam all the way from before it's manufactured to after it comes off. And because there was a lot of folklore going around about what foam was. And a lot of the foam, particularly the foam that we're talking about on the bipod ramp, is hand applied, and it's an art. And so we wanted to know all about that. So that's where that little saying about follow the foam was designed to encourage the people to dig into it as deeply as they could. As we had examined, and we got late in the investigation and understood more about the foam debris, and had run some calculations on the kinetic energy of what the speed of the foam, and by the way, that took a long time. We did photographic interpretation of the foam coming off and striking the wing, and we got a value for kinetic energy and a value for relative speed, and we went back and did it again and got a different number, and so it was contentious as to how fast that foam was going and how much kinetic energy he had. Kinetic energy being more important than speed. So we did some tests about how much damage it would do if it struck something, and of course then we wanted to know how strong RCC was, and whether or not RCC had holes in it, or pits in it, or manufacturing defects in it. So we wanted to know about the pedigree of RCC, reinforced carbon-carbon. We wanted to know how much testing had ever been done on reinforced carbon-carbon. And it was all very sketchy. It had been tested many, many years before, long time ago. It was only manufactured in one place in the whole universe, and it was all very not convincing. So one of our board members came up with the idea that we ought to go to the Southwest Research Institute that shoots rubber chickens at cockpit windshields and other things like that, frozen chickens at cockpit windshields, to see whether or not the windshield would scatter, to see whether or not we should do some impact testing of the foam. And we did some impact testing on some plastic mock-ups and things like that, and found that the foam appeared to be more energetic than we had been led to believe. So then the board, members of the board came to me and said, you know, there's only one way to settle this, and that's to build ourselves a little section of wing out of real, no kidding, RCC spares, or, you know, spares that they got lying around or something like that, and see whether or not you could blow a hole in the thing. And I was against it. I said, I don't think so. I don't think we need it. I don't think it's necessary to prove what we're going to prove. I think the controversy that it'll cause was just a battle we don't need, and I'm not sure what visualizing the final report, I'm not sure what this will contribute to the final report. They were very disappointed in that, and so they came back and they re-engaged again, and they went through with me more engineering analysis, more technical analysis of what they knew and what they didn't know about the energetics of foam. It was not an emotional discussion, it was an engineering discussion about what they know and what they didn't know, and what would be proved by actually shooting it at RCC. So I changed my mind. We took it down to Texas, and we made a couple test shots at very low speed to make sure the angles were right. Because one of the things that we were concerned about was that when the foam strikes the leading edge of the wing, we wanted it to look like the foam that actually struck the Columbia. I mean, we wanted it to shatter, you know, we wanted it to come apart, and we wanted it to look, we wanted our strike to look like that strike. And that took a couple test shots, which we did, and then they brought it up to full speed, and I didn't go. I wasn't there. I didn't go, not for any particular reason having to do with politics or notoriety or anything like that. I just had not put this test very high on my evidence matrix. I failed to realize the impact of what this test was going to have on the public and on the acceptance of the report. And then a lot of NASA people were there. A lot of NASA management was there, and lo and behold, on the test that was up to speed, was actually at the speed that the impact happened. It blew a hole in the RCC. And one of the things that really struck me was that 8 weeks before this, we had calculated how big that hole would have to be in order to allow hot gases to get into the interior of the shuttle and progress through the shuttle and melt things at such a rate. You know, we only had so many minutes from the first detection of heat until the wing came off. It happened very quickly. And we projected how much heat would have to come in, and we projected on the size of the hole. And we were saying it was going to be a hole about 12 by 14 or 10 by 14 or something like that. And lo and behold, it's exactly the size of the hole. And of course, that put an exclamation point on, that put a great big period on the end of the report. The foam did it. Well, I guess my key takeaway is never foreclose where these paths may take you, because I did not attribute that much weight to the evidence of us blowing a hole in the foam. I thought, yeah, we probably will. It probably will work. But I didn't attribute very much significance or weight to it. And I didn't know the impact it was going to have on the press and the Congress, and I didn't realize the impact that it would have of putting an exclamation point on the end of the report. I didn't appreciate that. It did. I'm happy that it did. I'm happy that what turned out to be such a positive thing, but at the time I didn't know that, and so it goes back to my axiom at the beginning: never foreclose where one of these paths is going to lead you. During the heart of the investigation, halfway through the investigation, when we had been through a couple of the forks in the road and we were actively pursuing foam as the cause, we had debris construction well along. We had finished the search, and we were now reconstructing the underside of the orbiter down at hangar in Kennedy Space Center. The photographic analysis was very mature. The telemetry and data recording reconstruction was pretty sophisticated. We knew pretty much what had happened, and the flight analysis, the thermodynamics and flight analysis were pretty sophisticated and pretty complete also. I was working one Saturday morning, and there were 2 or 3 board members there just working away, and I asked them to come in and have a cup of coffee with me, and I said, we ought to start speculating on how we end this thing. You know, how do we finish this? Because we're doing all this investigating, we're doing all this data management, and we're doing all this calculating, and it's time to envision how we pull this thing together. How do we start writing? How do we stop all these processes that are in place? How do we let some of these people go? How do we determine when enough is enough? How much is enough? And so we visualized the end product and things like that. And one of the things that we did, I offer it as a lesson, we decided to get out of town and go to Washington. And the last few little things that we wanted to put our arms around were some high-level interviews at NASA, some things having to do with budgets and history and things like that. Few little things like that, all of which were Washington business. But mostly we wanted to get away from the investigators and away from the rank and file and bring the thing to a conclusion. And so we did. So we moved the investigation to a small office up in Washington, and we devoted ourselves to summarizing and writing and getting it concise. And one of the things that I wanted to do, as far as style was concerned, was I wanted it to be written in the style of Time magazine or The Economist or something like that. And by that style, I mean, if you ever read a news article in something like Time or Newsweek or something like that, each sentence conveys information. They don't write in which there's a beginning and a middle and an end. Each sentence is an end. Each sentence conveys something. It doesn't set up the paragraph. There's not an introduction or anything like that. I wanted to write in that style. And I also, of course, didn't want the thing to look like it had been written by a committee of 13 different people. So the writing was a major effort. I hired professional copy editors, and myself and a couple other people read every single word, and where there were tense shifts or gender shifts or person shifts, we got them. We had to bring them all out. But the writing and the writing style was also important to me. And so we left Houston and locked ourselves up over there in Shirlington and produced the report. In the course of a wide-ranging investigation like this, at some point, this is difficult, but at some point you got to say enough is enough, and you got to stop expanding your universe of knowledge and start contracting, and get it down on paper and start your report. And I use a little gimmick that I've used before, which I call the good idea cutoff date, and it means that not that your idea is not a good idea, but the time is up. This actually is an old Navy term. When ships are getting ready to go on their 6-month deployments, there are all kinds of technical updates and improvements and information technology, communications technology, radar, improvements and upgrades that are being made to the ship. And at some point you got to say, stop. Okay, stop. The crew has to have time to learn how to use this stuff. We have to integrate it into the entire ship's combat system. I know that's a wonderful gadget you got there, but we just got to stop, and we're going to go with what we got. And that's the good idea cutoff date. So that's what we did. We were very happy with how much information we'd gathered, how much evidence we had produced, and how we'd organized it. And also moving to Washington allowed me to release a lot of people. I mean, that was clearly a turning point in the investigation, and all these investigators and investigative people that we had on contract and things like that, was an opportunity to cut them loose. The board, I thoroughly enjoyed working with this board. They were very diverse in their background, and they were all very outspoken. All of them brought a special zeal and a special angle, which contributed to the report greatly. One or two members of the report were not Washington insider kind of people, and they were beside themselves with why do they do that? I mean, can't they see that's wrong? And kind of plain language kind of questions about how stupid things can get. That's very refreshing to have somebody say, we don't have to put up with that. And, oh, yeah, we do. And then, of course, we had professional investigators who brought a great wealth of knowledge. And also we had people who work in hazardous occupations and were able to educate us as to how you act when you're doing something which is hazardous, and the dangers of turning a hazardous enterprise into a familiar, everyday, accepted enterprise in which you've lost track of the hazards. That's, of course, what happened in this particular case. The shuttle had flown so many times that people were no longer considered it to be an experimental vehicle, and they'd lost track of how hazardous it was. So we had people that did this kind of thing. We had people who were veterans, for example, of the nuclear submarine accidents in which the Scorpion and the Thresher were lost, and and the lesson learned about after you have 10 million miles under the sea under nuclear power, you begin to believe that it's okay, it's not dangerous. Yeah, it is. So all the board members brought a lot to it. They all brought a lot. They all contributed significantly, and their diverse angles was probably their greatest contribution. In the course of the investigation, as I mentioned, we had to kind of weave our way between wanting some material to be confidential. We wanted some opportunities to meet, discuss items privately, but then we also had federal regulations on commissions and boards, and also the requirement of Congress and the press to keep them informed and to be transparent. It seemed like public hearings was the best way to take material that was being scrunched in private meetings or in very technical and analytical meetings and make them public by reviewing the material in public, even though it had already been hashed out. And whether it was organization policy, safety, budgets, or technical analysis, the public hearing was a chance to show to the public what we had learned and where we were and what we're working on, and to reveal to the public what we knew. Very little new material came out of the public hearings. It was really a chance for the public to see into our workings. I would say that my philosophical axioms should guide you. That is, complex systems almost always fail in complex ways. Big organizations are like organic beings, and their first priority is self-defense. So be prepared for the defensive crouch, and don't foreclose any path that the investigation might take you. You do not know where it's going to end up.